Good evening, everyone. Today is my day 4 of my Leetcode journey, and today I'm taking problem number 2095, which is delete the middle node of a linked list. Means we have to delete. Sorry for today because I am not able to explain as much as possible for this code because it is a medium level code, and I am here just to speak English and upload a video at a day. So I will explain as possible. So let's start. So we have to. The problem is that we have a linked list. You know linked list where all the elements linked with each other by next means first elements next holds other elements address, so which can we travel in the linked list and find the elements and do operations on it. So the target is that we have to delete middle element on it. Means if we find the middle element of its, means there are four elements like 4, and we will divide it by 2. So our middle element will be 2. So if we indexing it 0, 1, 2, 3, so it will be second element. So we have to delete this one and generate output as this one. So we have to delete 3 and return the output as 1 to 4. So I have written code it for it, but this code is not properly running on Leetcode for every test case. It is basic for 3 test case only. So I'm not explaining this one, I am explaining this code. So here you can see that my Leetcode, where I have wrote the code, where you can see I'm not moving my arrow because it is typically difficult as I am using my finger. So here you can see that there is a class named solution. Means we are making a class because you know that CPP is our object oriented programming, where we use classes and objects instead of making different methods. So here this is just a description of a definition of single linked list, which is already written here. So I am skipping it, and now our code starts from here. So here you can see that there is a class named solution which is public, because we have to access all the elements of this class, so we will make it public. So in name solution class, which is public, we are making a function name delete middle. Means we are creating a function which data type is list node, means linked list. This is pointer which we use on linked list, and the function name is delete middle, which contains linked list node head means our linked list. So first we will check if the list contains 0 or 1 node. If our list contains only 0 means nothing and 1 node, so we will check the condition. If head our list is null ptr means null pointer, there is nothing, or means either this condition or this condition. So if our head is null ptr or our head next, means our first node, only first node, and their next node is nothing, only we have first node, means we have only one node and nothing is in forward. So we will delete head, means we will directly delete it. If there are 0, so we will nothing delete, and if 1, so we'll directly delete it. So this is for it. So return null pointer means it will return the value. There are no pointers, means no list elements, so we will directly delete head. Now we will our main process is starting from here. Here we are making 3 nodes which data type is list. First one is initialized with slow. Head means which is initializing first node, as I told you. This one is our head. And what about dummy? Wait a minute. Yeah, So so here two nodes are initialized slow and fast. I will explain you that why I named them as slow and fast. So we are initializing both nodes with our first element, which one is 1. Okay, so we will also set previous as null pointer. If you use doubly linked list, there previous is also there, which indicates first node address, or means first node before first node. So we are initializing previous, which is null pointer, because our both are pointing to first element, so its previous will be nothing. Tracks the node right before the middle node, which will track our before node of our target node. So move fast by 2 step and slow by 1 step. Here the main concept that our slow will step forward only 1 step and our fast will be track 2 steps. Now we are using condition here, while means we work until fast is not equal to null pointer and fast of next is equal to not pointer. Means we will work until our fast element, which is tracking 2 steps, will be last, or its next will be last. And means both condition will be satisfied, then we will exit this. If the both conditions are not satisfying, then we will be moved from this loop. So here we are checking that for first this condition is satisfying, so we will be set previous is equal to slow. Now we have our previous will be this one, and our slow will be slow of next. Our slow will be this one 2, and our fast will be fast next. It will travel 2 nodes. If our slow will be 2, then our fast will be 3. So now slow this and fast this one. Now again for it we will again move and check this condition also satisfying. So we will again set previous as slow. Now our previous will be 2, previous will be 2, and our slow will be 3. slow will be Slow will be 3. This one is slow, and our fast will be, first we track this, and now second step will be null, so our fast will be null. So as I told you that our slow will be third element and our fast will be after 4. It is null. Now we again go to this condition, and our fast of next become null ptr, and fast is also become null ptr. So we will exit from this condition. Slow is now pointing the middle node, as we see that slow is pointing to our middle element, which is 3, and previous is pointing, one second, previous pointing to the node before slow, and our previous is pointing that this one, which is before middle element. So we will be set preview of next is equal to slow of next. Means our preview of next will be now slow of next. So we will setting uh, uh, previous as 3. Now we are setting previous as 3, means our middle node. Now free the memory of deleted middle node. Now we will directly delete slow, because our slow is 3 and we have to delete it, so we will be directly delete our slow. Now we will return the modified head of the linked list. Now we will modify head as previous, because we have to return 1 to 4 also after the deletion, so it will return this linked list again. If we delete 3 and we will not connect in them both, the link will be breakdown. So we have to join again these 3 elements, so will be return head now. So this was our code which is written here, and I will show you it's accepting or not. Yeah, you can see here my code is accepting. So this was for today. Thank you for watching. Bye bye. Take care.